All right. What you need to do here, you already have this problem on Canvas for example 1. And we've done one like this in our ACT bell ringers already. So we're given x equals -6, y equals 4, z equals 2. You need to, as you know, substitute those values in for the variable that they're representing. So x is -6, we're going to plug -6 in for each of our x's. Y is 4, so we're going to plug 4 in for y. And z is 2, so we'll plug 2 in for z. Then as you know already, our order of operations, or how I learned it, please excuse my dear Aunt Sally, or for some reason the new fad is PEMDAS. I always write this with the M and D and A and S on the same line because we do whichever comes first from left to right looking at the problem. We don't always do multiplication first or always do division first, just depends. So here, following our order of operations, we do P parentheses first. So -6 plus 4 is -2. And then there's no more parentheses, we can simplify, so then we have to do our exponents. Exponents here is -2 squared, which is 4. If you put that in your calculator and you got -4, it's because you put it in your calculator wrong. You have to put parentheses around your -2, otherwise it will not work and it will give you a wrong answer. So we have -6 times 4 divided by 4. So we have no more exponents. So now we're with multiplication and division. Multiplication comes first from reading the problem left to right. So we do multiply first. -6 times 4 is -24. So we have -24 divided by 4. It's the only thing we can do, so we do it, and we get -6. So there's our final answer of -6. Now we are going to move on to example 4. You might say, well, why is it example 4 and not example 2? And that's because I felt like example 2 and 3 from your textbook were pretty easy, self-explanatory examples that I didn't need to do. And example 4 this is the example that corresponds with example 4 in your textbook. It's not the exact same example, it's just another resource for you that goes along with example 4. So this is all about combining like terms. So let's go ahead and look at this. We learned from our notes that we already took that a term is a factor or a number, a variable, or the product of both. Okay, so here's a term, 8x is a term, -4x squared, 12xy, 3, -7x, -2x squared, -11xy, and xy squared, all terms. A like term is the same variable with the same power, or no variable at all. So in this case, let's look at 8x. Its like term has to be another term with just an x. So looking through, we have -7x. So 8x and -7x are like terms, so we can combine them. 8x plus -7x or 8x minus 7x is 1x. We know 1 is the coefficient here, the number in front of the variable. That we don't have to write the 1 coefficient in this case, so you can just put x. I'm going to leave 1x here, but you don't need it. Then let's move on to our next term here, -4x squared. Its like term, again, has to also only have x squared. Like here's xy, it has 1x, so it can't be it because it's not x squared, and it has a y. This does not. So our only other just x squared term is there, -2x squared. So -4x squared plus -2x squared is -6x squared. And then we have a positive 12xy. Its like term is -11xy. Combine those. 12 plus -11 is positive 1xy. Then it looks like we have 3, and there's no other term yet that is only a number, so we just bring that down. And then same here with a positive xy squared. There's no other term with an xy squared, so we bring that down as well. So now simplified, we simplified it down into 5 terms, but that would be it in simplified form. I do have a quiz at the end of example 1 and example 4 on Canvas for you. So go ahead and attempt those quiz questions. If you have any questions on those, we'll bring them in tomorrow and we'll talk about them. Have a nice day.